Okay, our objective in today's lesson is students will solve radical and absolute value equations, and then we will use Desmos to check them graphically. So first we're going to solve radical equations, and there's basically three things you need to do when you're solving radical equations. The first thing you have to do is you have to isolate the radical. So you've got to get that square root and radicand by itself on one side. Then the next thing you're going to do is square both sides of the radical, or square both sides of the equation to get rid of that radical. Finally, you're going to solve it and then check for extraneous solutions, because when you square both sides, you introduce extra factors that might not actually be a solution to the equation. Okay, so here we have our first example. We have 2x is equal to 1 minus radical 2 minus x. So I want to get this guy by itself. I'm going to subtract the 1 and come up with 2x minus 1 is equal to negative 2 minus x. I don't really care about this negative sign. He's irrelevant because when I square both sides, anytime you square a negative, it ends up being positive anyway. But this is why you always have to check your solutions. So now I'm going to square both sides, which gives me, I'm just going to square that binomial. When I square a radical, I get the radicand. So if I square this guy, I end up with 2 minus x. And remember, the negative sign is irrelevant because when I square it, it ends up being positive. So now I have to expand that squared binomial, and it expands to 4x squared minus 4x plus 1. I have a second degree equation that I'm going to solve. So I've got to get 0 by itself. I'm going to subtract 2 and add x. And I have 4x squared minus 3x minus 1. And that's equal to 0. This actually factors. Again, you can decide how you want to solve it. You could use the quadratic formula. This one might be a little bit trickier to complete the square. Or you could, well, we want to do this algebraically, but you could check and graph it first to see how it factors or see what the roots are. So I know I can break up my 1 into just 1 and 1. I need a difference of 3, so that kind of tells me I need a 4x and an x. I need the 4 to be negative, the 1 to be positive, and that's going to get me my negative 3x. 4x plus 1 is equal to 0. X minus 1 is equal to 0. So x is either going to be negative 1/4 or x is equal to 1. I don't know if both of those two work, so we need to check, and then we're also going to show it graphically because that's a little bit quicker. So if I do my check, I'm going to do this over here. I'm going to start with negative 1/4, and I start with my original equation, so I have 2 times negative 1/4 is possibly equal to 1 minus radical 2 minus a negative 1/4. So this is negative 1/2. I'm just going to put a line here to compare. 1 minus. All right, so over here we have 2 plus 1/4. I'm going to make that an improper fraction. That's going to be 8/4 plus 1/4, which is a very convenient 9/4. I can take that square root, 1 minus 3/2, and that ends up being negative 1/2. So the negative 1/4 works. I'm betting that the 1 is not going to work, but let's check it anyway. So if I substitute 1 in here, I have 2 times 1, and we don't know if that's going to be equal to 1 minus 2, what is it, minus 1, and that is not going to work because this is 1 minus 1, 2, and 0, no. So I have one solution, negative 1/4. Okay, we're going to check with Desmos, and this is the one time that I'm going to type it in where you can see me type, just so you can see how easy it is. That little keyboard button, if you just pull that up, you can get to the keyboard, you type things in, and what I'm going to do is I'm going to subtract the other side. So that ends up being 2x minus 1 plus, and then the square root, and everything's going to be under the square root until you tab out from under it. So here is our graph, and you can see, I don't know if it'll let me, if I hit that point, it's negative 0.25. So again, we set everything equal to 0, so all we have to do is look for where it crosses the x-axis, and there's my solution, negative 0.25. So I want to solve this crazy one. Again, the process is the same. To get rid of a radical, you have to square both sides. It's just in this case, we have to square it, and then we'll be squaring it again. So we have a radical inside of a radical. Alrighty, so if I square both sides, the first time, I'm left with radical x minus 5 plus x, and that's equal to 25. Now I've got to isolate this radical, so that ends up being negative x plus 25. If you want to make it a little bit neater, remember, if I factor out a negative sign, you don't have to worry about it. I mean, that's why we check our solutions. So I did that. Now I'm going to square both sides. X minus 5. Over here, the negative sign goes away. I'm squaring the quantity x minus 25 squared. Let me scoot it up a little bit. X minus 5 ends up being x squared minus 50x plus 625. I add 5 and I subtract my x. 0 is equal to x squared minus 51x plus 630. I can't even write today. Okay. 630. That thing actually factors, and you could graph it and see, or you could put in, well, if you want to find the factors of 630, another way to do that with your graphing calculator is to graph 630 over x and then look at the table of values, and you'll see eventually you'll get to 21 and 30. So it does factor. X and 21 and 30. I need a negative 51. Actually, they both need to be negative because 630 is positive. So my possible solutions are x is equal to 21 and x is equal to 30. So we have to check our answers here, check our solutions. Let's see. If I check, oh, my original was a radical, so radical is actually easier than what you think. 21 minus 5 plus 21, that needs to end up being equal to 5. 21 minus 5 is 16. Am I doing that right? Yeah. So the square root of 16 is 4. So that's radical 25 when I add 4 to 21, and it does end up being equal to 5. So 21 works. If I checked 30, it's probably not going to work. 30 minus 5 plus 30, that needs to be equal to 5. So that's 25. The square root of 25 is 5, so we get radical 35. No, that's not going to work. So I have one solution. So here I'm just showing you that I put in my, my equation, I subtracted the other side, so it's essentially set equal to 0. And you can see it crosses the x-axis at 21, so that's how you can check your answer. Finally, we're going to solve an absolute value equation. These seemed a little bit easier than all the other ones we've been doing. Basically, for absolute value, you want to separate into two cases because the original could have been positive or negative. So if I do that, I can have 2x plus 3 is equal to 4, or 2x plus 3 is equal to negative 4. And then you solve both, and you would have two answers here. So 2x is equal to 1, x is equal to 1/2, 2x is equal to negative 7, x is equal to -7/2. So we're going to check this with the graphing calculator. Again, I'm going to subtract the 4, so we're going to set it equal to 0. There's your absolute value symbols. I can put in 2x plus 3. And then I come over here, the little right arrow to tab out of the absolute value. I'm going to subtract the 4. And there you have it. I have an answer at -3.5 and at 0.5. So again, this is how you can solve algebraically and then check your work graphically.